Hello, everyone. Okay, I think I need to approve this. So very nice to be here. Thank you for inviting me. Thank you to all the organizers and this nice show up. It's really nice to see people in person and without masks. So it's a very special seminar. Right, so what I'm presenting here, as you can see, the long list of co-authors is joint work with a large team. All of them are either currently affiliated with the Growth Lab at Harvard University, or they used to be there. So myself, Shreyas, and Frank and James are still affiliated, and Andreas Humsao is now at the University of North Carolina, and Dario Deodato is currently at the Joint Research Center in Seville of the European Commission. This specific paper is motivated by the great transformation of, by now, like a little bit of an old technological change in the United States. So our data is for the United States, and this is a very empirical paper. Basically, what I will be talking about is what happened to the workplace from the perspective of men and women in particular, as computers spread out through the American workplace. So if we would be able to peek inside the offices of the 1960s and the 1970s in the United States, you would see that it was very gendered in a way. So statistically speaking, half of the female employment in the 1960 was employed in clerical and secretarial jobs. Well, this was only the case with 7% of male employees. So most men were working in manufacturing and industry more generally, and most women were in services, in particular administrative services. Now, the computerization starts already in the 1940s, but it's very, very specific. It starts with mainframe computing, which is very specific to certain sectors and certain occupations. So when we talk about the computerization of the American workplace, we're actually talking about the 1980s. It doesn't really take off until the 1980s. So in the 1975, there were literally zero personal computers on the American desks. And this goes up to over 1 million by 1980. By the end of the 1980s, 40% of the American workplace has computers. So it's a very rapid adoption, but it starts in the 1980s. Okay. So one thing that happens is that there was a lot of technology on people's desks, as you might have seen on those previous pictures that I showed you. They were not computers, but they were things like stenographers and mimeos and accounting machines, addressing machines, calculators. They were all replaced by a single gadget. This development, and this is where I will get to the research question, coincides with the dynamics of the gender pay gap. So what you see here is the development of the gender pay gap in the United States, which basically measures how much do women on average earn for every dollar that men earn. And it's not adjusted for characteristics. So it's just like a economy-wide average. And what you see, it varies a little bit by how wages are estimated, but it's about 60 cents. Women earn 60 cents for every dollar that men earn throughout the 1960s and 1970s. And then around the 1980, it really takes off in terms of closing. So nowadays, women earn about 80 cents per dollar. Now, the question is whether these two developments, the computer adoption and the closing of the pay gap, are related. That's our research question. So there is theory already built around this question. It comes from Galore and Whale. That's one of the theories. So Galore and Whale have this theory of technological change and capital accumulation, fertility, and the gender pay gap. It's a very old paper, but basically they had the same image in mind when they wrote this. So they lived in time where they saw this great transformation of the workplace, and it had a very serious gender component. So what happened was that prior to computerization, most women were doing some kind of cognitive work, and most men were doing some kind of manual work. So they start with the premise that men have higher endowments in higher physical endowments, while both men and women have equal cognitive endowments. And as a result, men have comparative advantage in manual work in the American workplace and women in cognitive work. And that's kind of what we were seeing on the workplace before computers. Now, technology, especially computers, complements cognitive work more than it does manual, right? It doesn't, by their model, it doesn't even have to substitute for manual work. It does, but it doesn't have to. This dynamic of computer technology complementing cognitive work more than manual work results in higher increases, higher gains for women in terms of pay over time as a function of computer adoption than for men. So as women's wages are increasing more over time, the opportunity cost of having children is increasing as well. So women are having fewer children, more women are entering the labor market. That's kind of the first order prediction. So we will see more women on the labor market. And second, their wages will grow relative to men. So we will see closing of the pay gap. However, less than a decade later, this skill bias technological change hypothesis was replaced by a more nuanced one, which is called task bias technological change. By the way, feel free to ask clarification questions throughout the talk. So discussion is for later. Can I drink this? Okay, great. So the task bias technological change is a little bit nuanced. And the important nuance here is that it says, well, computers do not strictly complement cognitive work. They complement non-routine cognitive work. And a lot of the work that women were doing was actually routine cognitive work, which is actually being substituted by computers. So in the end, you don't have such a straightforward hypothesis about what will happen to the pay gap. So next we went to the empirical evidence, and it's quite mixed. So for Germany, there is a very nice paper by Black and Spitz-Oehner, and they show that indeed that women specialize in routine cognitive work before computers, but they managed to catch up, not just catch up, but overtake men in upskilling to non-routine cognitive work. So they went from, let's say, being secretaries to being in professional jobs and in technical, more technical jobs over time, which closed the pay gap. In the United States and in Portugal, and this is a more recent paper by Cortés Oliveira and Ana Salomons, they actually find quite mixed results. And in some cases, and particular for the United States, they find that computerization actually expanded the pay gap, it didn't close it. Okay, so anyone working on this topic knows that there's huge literature behind it, so I will not do justice to all of it. Maybe some of you are working on it, so I want to know in the discussion part, so please familiarize me with other work that is being done. But generally we follow three tracks. One is the literature looking specifically at the relationship between technological change and the pay gap. The second one, and this is kind of the major contribution of this work, is that we create a new data set which uses textual data on occupations to create quantitative longitudinal data set of occupational work content. So I'll talk a little bit more about it. And there is a growing literature, very fast growing literature that does similar things. And the last literature is this task-based approach. So I will talk a lot about work activities and job tasks, which means that we will not only look at wages and gender and education, but we will be looking at what people do at their jobs. Okay, so the first contribution is this longitudinal data set. And the second contribution is just the findings from the empirical analysis of the data set. For those of you that need to run or are bored already, let me give you a summary of findings. So what we find is that computerization has two offsetting effects on the pay gap. On the one hand, it increased the female share in computerized occupations. So it brought more women on the labor market. And it placed them in better paying jobs because computerized jobs are better paying jobs and are actually, their pay grows faster over time than in all other jobs in the economy. So that force helped close the pay gap. But there is a different force, which is the fact that when men use computers and women use computers, the return that men get from the use is higher. We can discuss why this could be the case, but as an empirical fact, it is. And this one, the differential returns to the use of computers between men and women go in the direction of widening the pay gap. And the second effect is higher. So it offsets the first one. So in the net, computerization increased the pay gap. I will come to the conclusions with more details, but I think it's by 15% of the increase of the pay gap is due to this net effect. That's what we find. Well, if we would have let computerization be the only factor that affected the pay gap, then we would have seen 15% increase in the pay gap, not closure. So the closure is due to other factors. Okay, so let me first say a few words about the data set. So we aim to create a data set that stretches from the 1930s until today for the United States. And for every occupation has information about the job tasks that professions do and the tools and technologies that they use. The first source of information comes from, oh, my connection dropped. Should I just continue or wait until we connect? I don't know when I dropped out. But... It's usually will just connect by itself, but I just don't know. Somehow you want to get to the the Wi-Fi's.
Maybe we should use some local one.
Some local one? Some local computer or
local, Wi-Fi.
Yeah.
Oh, you're back.
Oh, yeah, I'm back. Okay. Apologies, everyone.
You have to reshare probably your screen.
Reshare the screen. Good. Thanks for that. Okay, now it should be good. It says sharing screen. All right. So the first source of data is what is called the Dictionary of Occupational Titles. It's literally a dictionary of occupations. This is the first page. So you can see it has a job title. Sometimes it has a number, sometimes not. And then a short paragraph of what that occupation or job title is doing. It's focused on the work activities or job tasks. I will use these terms interchangeably, but not so much on the skills that one needs for it or the tools and technology. So So the best content that it presents is really on work activities. What exactly do you do at your job? From these, which in the 9039 version, for instance, are 27,000, more than 4,000, you can see my cursor, more than 7,000 have codes. And these are the titles that we use. And the number of codes increases over time. So there are four editions, and there is like a major revision in 1991. That's kind of like the 5th edition. So we basically OCR'd all of this, and then we ran an NPL text classification model. So we ran pre-trained BERT model, which I don't know how many of you use text analysis, but it's what Google invented and uses on its search machines to guess what you're searching for. So if you do a Google search and Google is like guessing your next word, it's using BERT. So that's what we use. But in this case, we also use it, and I'll come to that, to kind of assign labels to these paragraphs.
So 1991 is your last
Yes, so 1991 is the last. In 1998, the DOT was replaced by a digital successor. It's called ONET. And we merged what we created with ONET to create one longitudinal data set. So our data set ends as of now in 2019, but we can update it. ONET is well, every year they update like 100 occupations. So within 10 years, they kind of update all occupations. So what it makes most sense is that you kind of take once a decade mark, because occupations don't change that much year by year. Yeah. But this exercise ends in 1981. All right. So here is the comparison between ONET. So this was a very good time to ask ONET, which started in 1998, and it's being updated currently, has one thing in common with the DOT. What they have in common are these short paragraphs that describe occupations. So here is I will be giving the example of a secretary just to kind of for continuity. So the administrative and executive secretary, this was an occupation in 1939. In ONET is split into administrative and executive secretary. That's not very relevant. What's relevant is that in both cases, you can see how they're described. So, however, what ONET also has is for every occupation, it has something called general work activities, GWAs, intermediate work activities, which are nested within general work activities. It also has detailed work activities. It has tools and technologies. It has interests, work characteristics. It has like several different categories, skills, abilities, knowledge for every occupation. So you can basically relate the text here with these labels, if you will, that are systematically reported for each occupation and could change over time. So basically we use ONET to train BERT to associate these kinds of labels with these paragraphs, with these short paragraphs of occupations. So you can see here examples. So an example of GWA is that an occupation does analyzing data or information, and IWAs then further breaks it down to whether you analyze industry conditions, like market information, or you analyze health data and so on. It's a long list. And then we assign, so with the help of this text classification model, we assign what the probability, so it will be a 0 to 1 for each of these tasks. We will have a probability from 0 to 1 of whether, for instance, controlling machines and processes is present for secretaries, whether analyzing data or information is present for secretaries, and so on. So this is how they look like at the end. So as an example, in 1939 and 1949, these are the top most likely tasks for a secretary, and these are the bottom most, or the least likely, the five least likely tasks for a secretary, right? So a secretary never did repairing or maintaining of equipment or controlling machines, but they did these things like getting information, updating knowledge, and so on. So there are dynamics over time. So for instance, again, it's for the secretaries. This is a task that never changed, which is they were always getting information. Another task that they never did and never changed, which was operating vehicles. But for instance, interpreting information became more common over time, and selling on or influencing as a task became less common over time. So we can see these dynamics within occupations of task content. Okay, tools and technologies, we would have loved to just get them also from the DOT, but that was not the case because DOT is not consistent in mentioning whether an occupation uses tasks, tools or technologies. So here we found 3 books from the 1940s, and they look something like this. So for office occupations, here's an example of an audit clerk. So it will have a job summary, which is very similar to the DOT paragraph description. But the very interesting part is they're going to tell us what kind of machines they operated. And in this case, this is a typewriter. These are all actually typewriters. I think one of these is maybe like a bookkeeping machine. Okay, so that's where we get the tools and technologies from these 3 different books. All right, so we identified, it's not an exhaustive list, so it's far from perfect. We hope to get this part better in future. But just to give you a sense, so in the 1940s, the most common non-office tools are, this is not optimal with the, okay, hand tools, blueprints, drawing tools, hoist, hammer, measuring device. It's like a lot of kind of manual manufacturing stuff. And then the office tools are telegraph, telephone, typewriter, calculator, switchboard, stenotype, and radio. Okay, so this is kind of like trying to piece it all together. To piece it all together, we have 6 breaks in the occupational classification between the 1930s and today. So we had to come up with some way of synchronizing, and I'm sure lots of you have worked with classifications and you know that's very difficult. So Dario, who's part of the team, came up with a network approach where he basically links all these classifications into one big network and does cluster analysis. So our occupations are actually clusters of occupations that occurred over time. And the links come from the fact that in concordances, they have been linked through a concordance. So basically, we end up with 585 occupations that we can track over time. In fact, only 266 we can track in all decades. The other ones are churning, so they appear or they disappear. But these 266 that you will also see in my statistics, those account for 85% of the total employment. So they're really the bulk of the American employment. Okay, so the years are, apologies for that, from the 1930s to 2019 by decade. We have 40 predicted general work activities, 332 intermediate work activities. If you're familiar with Acebolu and Autor's work on technologies, we also have those 5 routine and non-routine tasks as a validation. We have the predicted use of computers. We have actual use of computers and predicted use of computers, meaning that we can say, if these were your tasks in 9050, and if there were computers, would you have used, what would have been your probability of using a computer? I'll talk a little bit more about this. The tools, and we merge all of this with census data from IPAMS. So we will have a whole lot of characteristics that we, in this version of the data set, we average, well, sometimes, I guess most of them we average, some we aggregate, depending on what makes sense. But we know the distribution of age, of gender, of education, of pay for those occupations. Okay, any questions so far? Because we'll go into the analysis. Any questions on the data set? Okay, cool. All right, so first we do a couple of things just to validate the data set. And one thing that we, something's off.
You have to know this somewhere.
That's better, yeah, thanks. Okay, so one thing that we do to validate the data set is to compare the trends in tasks with what has been found in the literature so far. And this is where these 5 routine and non-routine tasks from David Autor's work and Daron Acemoglu's work become interesting. So they have data that starts in 1960, but in fact they do not have tasks that change over time before ONET, because this just didn't exist. This is kind of a contribution that we are making. But basically what they're showing is that since the adoption of computers in the 1980s, we have increase in the demand for analytical. This is in our case, non-routine analytic tasks and non-routine interactive tasks. There is a decline in the routine cognitive tasks and the routine manual tasks. And that's kind of what we also see. We see less of a decline in routine cognitive tasks than they do. But in general, these patterns are quite consistent. It's also quite interesting that there is very little change in some of these before. We see only monotonic decline in non-routine, in routine manual, because there was a wave, we think, because of the wave of mechanization before computerization. So there was a lot of mechanization in this period before really digital technologies kicked in. All right, now coming to the research question, the question is, how did that picture that I showed you compare between men and women? And if you, so these are just the differences in the probability of performing certain tasks, these 5 different tasks, between women and men. So values that are positive means that women accumulated, not accumulated, but are using more of that task over time. They perform more of certain task over time. If it's negative, that means they do less of that task over time compared to men. So basically what we find, and this is in line with what Black and Spitz-Oehner found for Germany, is that women compared to men, and coinciding again with this period of fast computerization, acquired more non-routine analytic and more non-routine interactive tasks, which are the tasks that are complemented by computers. At the same time, they specialized away from occupations that use non-routine manual, and to some extent, they specialized away from occupations that use routine manual tasks. So that's what we find. So this kind of, if you see this, and if you think about these 2 purple tasks, the analytic and please.
So I really liked the Black and Spitzer paper. I was envy when I first read it, but I think they have two very important messages. That not only the between occupation gender gap is decreasing, but also the within occupational task converge between men and women, and that helps to people to women to catch up. And since you are using this occupational task data, you cannot measure within occupational task differences. So basically, I guess you are measuring the effect of segregation across occupation and how it evolves over time. And it's okay, it's fine. But do you have any idea how this within occupation task segregation changes?
Yeah, we do. So to be upfront about this, so the caveat is that we cannot say that the advantage of Black and Spitzer of their data is that it's survey data. So the task averages for women and the task averages for men. That we don't know. So we cannot do everything that they do, and we cannot do precisely the shift share analysis that they did. But what we can, but we know the initial occupational specializations of men and women and how this changed over time and how the task averages in all of these occupations changed. So we can do a shift share analysis, and we have done it. And what we find is that, so first I tried this, but for some reason my links don't work, but I can, let me summarize it for you now, and in the discussion part, I'll show you the details. But what we find from the shift share analysis is that in the US, most of the shift is between occupations. So it's occupational desegregation. So the reason why, let's say we see this relative increase in non-routine tasks for women over time is because women are going from clerks to professionals, from clerks to technicians, from clerks to managers, and men are doing less so. So this is, and what Spitzer and Black find is that the leading mechanism in Germany was that secretaries are just getting more analytic and interactive tasks, right? So in their case, it was the within change that dominated. And in our case, it's the between change that dominates. Yeah, this looks right. Okay, does that answer your question? Is that what you were asking? Okay, good. All right, so let's go on. Now, we want to kind of put a more tight connection between our variable of interest, which is the pay gap, and the change in computerization. So the pay gap can change because of two things. It can change because of the employment channel. That means the share of men and women, the proportions of men and women are changing within occupations, or it can change because men and women are paid different rates, and these rates change over time. So we're going to look at both. So the first set of regressions that I'll show you will be looking at how computers, the computer adoption, is affecting the change in the female share. So for every occupation, O, the outcome variable is the change in the female share. Very specifically, we count the hours paid by women and the number of hours paid by men. So it's basically the number of working hours. It's the share of working hours performed by women. So that will be the female share. So it's not just whether you work or not, but also it's corrected by the number of working hours. Okay, computerization is comes from ONET. And it was first reported in in 2000, and since then every year. And basically it asks how important is interacting with computers in your job. And this is a Likert scale. Initially it's like between 0 and 5. We rescale it to be between 0 and 1 for easier interpretation. So 0 means it's not important at all. 1 means it's extremely important. Now, as you can see, we don't measure computerization prior to 2000. So we basically need to take a year where we know for sure computers were not there. And that year for us is like 1970, based on everything we have learned about the diffusion of computers in the US. So basically this delta will be estimated between 1970 and some recent year, either 2000, 2010, and 2019. In the estimates that I'll show you, it will be an average over these 3 years. But our findings are quite sturdy if we take one of these 2000, 2010, or 2019. Okay, and then we'll have a bunch of controls that I'll show you in the regressions themselves. We always control for the initial conditions. There is a mean revision term in both cases. So if you had high share of women to start with, there's only that much you can go. So you have to kind of control for the initial conditions, or if an occupation was already paying high wages, you know, there is also, you have to control for those initial conditions. So this is just this is kind of like the mean reversion term here, and this is all done by occupations. So this for this we did it both for the 266 that we follow over time, and I think those are the regressions I'll show you, but it doesn't change very much if we add also those that are churning. Okay, so we had to, there are of course issues with identification. One issue is reverse causality. Anyone who follows the literature on technological adoption probably knows that it's not random, right? So especially in our case, if you think like better paying workers, maybe you know, more complementary to computers, so they will adopt computers faster. So we want to shut off that channel. So we only want to use the channel that made certain occupations before computerization more likely to adopt computers. So a similar strategy like the one we employ is used by Gretz and Michaels. I'm probably butchering the first name. If anyone has read Robots at Work. So basically they have the same problem. They're looking at robot adoption, but robot adoption is not random. So they say, let's figure out what are the tasks that robots came after. And that's kind of the same strategy that we're following. And what we use is this predicted probability of using a computer in 1970. So before computerization, given what your you know, job description was, if there was a computer, would you have used it? What would have been your probability to use it? So that's kind of the first instrument. The second instrument is are the tools and technologies used at the workplace in the 1940s. So for instance, if you use a typewriter, if an occupation used a typewriter in the 1940s, it typically has a high probability of using a computer if there would have been a computer in the 1940s, but there wasn't. If you're using an accounting machine, you also had high probability of using a computer if there would have been one. So that's kind of the reasoning, just capturing this variation that comes from the initial conditions of occupations the initial propensity of occupations to have used computers if those were available at that time. Okay, and then we have a bunch of omitted variables. I already mentioned there was a large process of mechanization that started before computerization. Later came robotization, I think in the 1990s, intensified in the 2000s. And then the third confounding factor can be occupational upgrading. So this period is also accompanied by huge occupational educational upgrading, and it's faster for women than for men. So basically, if you have women acquiring education faster than men, their wages may be growing faster because they just have more human capital, and it has nothing to do with computerization. So we will also control for the changes in the college, the changes in women or men with college education. I think this will become more clear in the tables. Okay. Yeah, and we don't have, unfortunately, we don't have direct measures of mechanization and robotization, but we studied which sectors were affected by this, because it's more of like a manufacturing. So it's mainly automotive and a couple of other sectors. So we're going to just exclude those sectors that were affected to see whether the relationships whether the relationships remain. Okay. So this is the first set of findings. So here the research question is, how did computerization affect female employment? Or did it have an effect on the share of women working in an occupation? So here are the OLS findings. In this case, we find that, when computerization in occupation went from 0 to 1, so from not being important to being extremely important, those occupations increased the female share by 33 percentage points, 34 percentage points. Once we start instrumenting for computerization, the results don't change very much, so it goes up. So this is with predicted computerization or probability of computerization as a instrument. In this table, I don't have the ones with tools and technologies. Maybe they're in the appendix, but it's very similar. We also wanted to do like a placebo test. So we said, well, what if we run the same regression, but instead of looking at the changes in the female share between 1970 and today, we look at the changes in the female share before computerization, so between 1940 and 1970, and we see nothing, which is kind of quite reassuring that this is something really of the computer era. Apologies. What else do we do? Okay, so then we said, okay, so is the assumption that 1970 is the 0 year, where there, computerization is really at 0 for all occupations? Is that too strong? So we said, let's look at the relationship for the period where we actually have actual measurement of computerization, 2000 till 2019, and we find the same relationship. Actually, it's very similar in scope, in magnitude. Then we do these subsets of industries where we include industries that were prone to robotization, mechanization, and again we find relationships of similar magnitude, and all of those are instrumental variables. So our conclusion here is that computerization had an important impact on increasing the female share. And if we translate this in aggregate, so computerization went from 0 in 1970 to about 70% on average between 2000 and 2019, which translates into an effect where computerization would have brought about increase in the female share between something between 30 percentage points and 33 percentage points. So, given the diffusion of computerization between 1970 and today, the female share on average in the American workplace should have increased by about 30 percentage points. Now, the factual increase was only 13. So this overpredicts, which doesn't make it wrong. It just means that probably there were other factors that counteracted it that we're not looking at. But otherwise, if computerization would have been the only factor on the workplace, there would have been more women in relative terms than there are today.
Do you have a story why the OLS is biased downwards if we believe in the two SLS regressions?
One thing is measurement error, to be honest. That would be my first guess. These things are measured with a lot of noise. And what IV does, in addition to, correcting for omitted variable bias and other sources of endogeneity, just corrects for measurement error. So that's my best guess. You have other ideas?
No, that's why I was asking.
Okay. I don't think that they're like statistically different. So if you see, if I would like check, if I would do an F-test across these coefficients, I don't know if they're really statistically different. But it's a good point. Yeah. Okay. So in this case also, like, this educational upgrading doesn't do much, but it will be very important for wages. All right. So the second set of results concerns wages. So here we ask, did computers increase wages, and did they increase it more for one of the two genders? So the first order results is that computerization increased the wages across the board, both for men and for women. However, it increased them much more for men than for women, which is this second offsetting factor. So although it brought in a lot of women on the workplace into well-paying jobs, the returns to using computers are higher for men, actually are double those of women. Now, we cannot tell what exactly drives this. It could be that women, a secretary can use, a secretary may use a computer, let's say within a secretarial job, a female secretary could use the computer mainly for, let's say, typewriting and data entry, and a male secretary maybe is doing some kind of more analytical work. So that's fully possible. We cannot test for that.
I've been wondering whether you looked at for what exactly they are using the computer. So like in programming or coding. So I guess this is still very much more man dominated jobs. And would it be possible to look at, for instance, the degree needed for those jobs? Like if computer science degree is needed, then my guess would be that these are man dominated.
So have in mind that this is already within occupational analysis. So we are comparing male engineers with female engineers. We're comparing male scientists, computer scientists with female computer scientists. So these differences are within occupational. So, but if a male computer scientist uses computer for, slightly more advanced programming, the female computer scientist, you could theoretically see these gaps. But since and this is to your point, unlike Black and Spitz-Oehner, we don't have survey data where we have asked, a sample of women and sample of men within the same occupation, what their tasks are, we cannot answer that question precisely. So we have the average task use or the probability of doing a task by occupation, but not for men and women within that occupation. So that would be terrific. It's just that that data does not exist for the United States. Also, ONET doesn't have a gender. In the latest survey of ONET, they don't. Somewhere in their records, they keep track, because I took the survey just for the experience, and they know that I'm a female economist. But when you go to the ONET data, they don't make that public. So, but if ONET would make that surveys public, then we could tell more whether, computer scientists, male computer scientists do different tasks that female computer scientists, and so on for different occupations. That would be very interesting. Cool. Yeah. Yeah. So the controls are like pre-trends. In some of these estimates, we had pre-trends. So we control for pre-trends in wages between 1940 and 1970. So in the pre-computer era, we control for changes in hours worked. There is a large literature that says that the reason why women managers cannot get the same pay as male managers is that they're more restricted in the hours that they can provide and the flexibility of hours they can provide. So we're trying to control for that. And I don't know why I don't have here the ones with controls for educational upgrading, but definitely we have them there. But that one, let me maybe go. Yeah. So here in the appendix, I have the ones with controls for educational upgrading, and when you take those, you see that's very important. So part of why wages, why the pay gap actually declined, is because women got more education than men, and you see that educational upgrading shrinks these coefficients, right? So basically, part of the increase in pay is due to computerization. Part of it is due to educational upgrading. Yes.
Can you elaborate a bit more on this? How do we understand this data college?
Yes, absolutely. So
it is like your dependent variable is the share in the wage, the change in the wage in an occupation, depending on how much it was computerized, and you measure this the change of the women working in occupation which are more computerized and less computerized. But I don't see what is the delta college coefficient. So the share of women having a college degree who are working in these occupations.
So this is in the so the variable is the change in the share. So in the estimates for women, it is the change in the share of women with college degree, and between 1970 and today.
For this specific
occupation, yeah. So yes, so these 266 are occupations, and these changes are within occupations. So this is, for instance, the share, to give you like a specific occupation, the share of secretaries with college degree, the change in the share of secretaries with college degree between 1970 and today. That's what the control is.
I don't see why did you say that it actually, so the educational upgrading, why did it close the gap between women and men? So in my reading, the coefficient for men is larger or the same.
Right.
similar to that of women?
Right. Actually, this is, I'm really glad you're asking this because I haven't done this. I haven't done this, but I should do it, which is, I think after you control for the educational upgrading, the difference between these two is not as great than the difference. Well, this is well, they're both subsets, so I should compare this subset with this subset. So you might be right that I cannot say that. I need to compare if the difference between these two coefficients is smaller than the difference between these two coefficients. And if it is significantly smaller, then I can probably say what I did and otherwise not. But yeah, that's a good point. I kind of, yeah, I think I relied on previous literature. So one of the leading explanations about why the pay gap closed in the US, and it's work by Claudia Goldin and co-authors, is that women just caught up on education, which to me it's very strange because it doesn't explain why didn't they do it earlier. So you also have to kind of explain what happened. I mean, in many countries, I work in a lot of developing economies and people catch up on education, but there are no jobs for that education. So it doesn't really translate into higher pay premium. Sometimes it translates into lower pay premium because there's oversupply. So there is no, for me, automatic translation. You get more education, you get higher pay. You get more education if there are jobs that, you know, use that education. And I think matching that finding about educational upgrading with the technological change that actually demands that education makes much more, for a much more complete explanation of why, you know, why women could enter and why they could get good paying jobs. Was there another question at this point? Are we on time? Okay, cool. Great. So the last thing, okay, so this is kind of just like to translate what these numbers mean. So wages for women increased between 80 and 140% in occupations where computers became extremely important. So from not important at all to extremely important. And for men, this increase was between 90-70 and 280%. That's what the numbers, because it's a log wage. So if you change in the log wage, so if you kind of translate that back to percentages, this is what you get. It's kind of double. So it's a very strong offsetting effect. So the last thing that we try to do is to compare these two effects, and it's kind of not as trivial as it looks. So what we came, the conclusion we came to is that the employment channel can account for 3.3 percentage points of the closing of the pay gap, which is about 25%. So a quarter of the pay gap was closed because more women entered the labor market and got into well-paying computerized jobs. But then this counteracting channel, so the differential pay for men and women, because for the use of computers, can account for almost 6 percentage points increase in the pay gap. So that's about 40% increase of the initial pay gap. So this cancel out to an extent, and the net effect is widening of the pay gap. So we have like 15% widening of the pay gap if other factors would not have been around. So we conclude that there are other factors that close the pay gap, and it's not technological change. Actually, there's an interesting paper that came out last year on robotization across Europe. And they find something similar. They also find that robotization, but they only look at the pay channel. They don't look what's happening with employment. And they also find that it has a widening effect. So So that kind of was nice to see, because this is not what we expected to see. Yeah, so I think that's what I have. So I have some backup slides. So if you have any questions, I can maybe go through them.
And can you control for other changes in occupational characteristics? For example, computerization decreased a lot of other activities within occupations, which may also affect the effect of computerization. Or it's more simply saying that that computerization is correlated with other characteristics of the jobs, which affects pay at the same time. So we should control for that.
Yeah. Well, do you have like more specific
like
examples,
for example,
like what you have?
using these interpersonal skills that you showed the figures at the beginning, or the use of manual skills or whatever. And I am pretty much sure that they are correlated with computer use, and they affect the wage gap as well.
Yeah, we also try to also work with what's happening with changes in tasks and how they affect directly wages and employment. And it's kind of, I mean, it's harder to work because, I mean, like we have 40 tasks and you have to have hypotheses more specifically about, so if you would have more specific hypotheses about like specific tasks that should have affected, then
you made 4 aggregate time series at the beginning as a suggestive evidence, and you could put there as a control variable this and this is.
Yeah, the issue is that if you say like computers are changing the tasks, you know, and then tasks are changing the pay, then kind of the root cause is computerization. That's kind of the argument that we're using. So you can easily show these correlations between changes in routine work. So we can see when in occupations that deroutinized, you see that the pay went up. So deroutinization. So we have some of those estimates, but it's harder to say, okay, we have the root cause of tasks changing, but we're gonna control for the tasks changing. That's a little bit harder to wrap my mind around, and maybe I'll need to think a little bit harder about what makes most sense.
I have a theory. I mean, I'm sorry on you for this. Maybe one of several of these tasks changed in a way that they became less interpersonal and more, via computer based, like, now sending emails instead of going there and talking to each other.
Yeah.
While in the first one, talking to each other, probably women are better. In the second one, men are as better as women. So in these sort of tests are changing in a way that they favor men.
Yeah. No, interesting. Yeah. So basically, you would say, okay, so then you would not look at, then it would be like a more nuanced question about the tasks changing and what it does. Yeah, no, definitely we can. So yeah, we need to have like more specific hypotheses about what matters, because as you saw, like we have 40 general work activities, then 332. So you have to really have a very clear idea of what to exclude and what to include. We have also done like factor analysis just to say, okay, we're agnostic. So we let the data speak about the dimensions in the data. So we have done that too. It was just so difficult to interpret. You see a lot of things and a lot of interesting things. So, but you need to kind of come up with something more tidy and of a story or a theory to kind of make good use of the results. So thanks for the idea.
I'm just wondering whether this question can be and should be investigated only in this light, say that this gender. What about the other discrimination dimensions like minorities and all the others? And especially in this last 2-3 decades, that was really affected and dominated the US labor market.
Yeah.
So then I'm just thinking that perhaps that should be in a way at least considered how this might affect what you are looking at.
Yeah. No, definitely. I remember when I was preparing the data set, like I pulled out a bunch of, so the census, it's really easy to, go into these questions with this data set because we linked it to the census data. The census data has very detailed racial and ethnical, and you can even like see the ancestry of people. So you can, it's very detailed on those dimensions. So we haven't looked into it. They are part of the.
What do you think? What do you think now?
So what I saw is that the gaps, the racial gaps, were not as large as the gender gap. So we started with the big gap because there's just more to explain. And there was a theory on why technological change could affect the genders differently. And so that was why we started with the gender gap. But so we'll need to look more into the specializations, but one can look into the specializations of the African Americans, Hispanics, and other groups before computerization and after computerization and build up similar theories. And the empirics are there, the data is there. So one can look. I don't have clear hypothesis as of now. There is definitely huge occupational segregation by race in the US, but I'll have to see like what are the African Americans specializing in and how the specializations have changed and how that may relate to whether they're getting into more computerized jobs or not. But it's definitely a very relevant question and something, if someone wants to work, we have the data. Yes.
We have time for one final question, which is coming from the chat. Can you speculate about how your findings would replicate in other countries, specifically countries with gender norms different from the US, from Sweden to Iran?
So you said Syria and Iran, or from Sweden to Iran. From Sweden to Iran. Oh God.
Question is from Johannes Fox.
Oh yeah, the hardest are always from my colleagues, my dear colleague. You should be on vacation. No, he has 2 more days. Let me think. What I found very interesting that even countries like Germany and the US had from what we know, so in the US, men and women were equally likely to do routine work in the 1950s and the 1960s because the manual work in which men specialized in the US was also very routine. So in that sense, they were both prone to deroutinization through computerization and mechanization, although they had very different jobs. In Germany, what Bleckenspitz-Oehner find is that women were much more specialized in routine work than men prior to computerization. So I was struck to find this difference. We worked very hard on figuring out whether there is something wrong with our data because their paper came first, but we don't find anything strange with our data. So we conclude that although these are both like relatively developed economies and kind of went through many similar transformations, that it's really possible to have very different specializations between the genders in the past and probably today. How this will play out in countries with, I would think that, I don't know the history of Sweden, but knowing that female emancipation, whatever that word is, came relatively early, I would think that the changes should be less pronounced just because there was less to change. So if women and men had more equal job tasks in the 1960s and the 1970s, then there is less to reform, right? So that the gaps would be smaller and the changes will be smaller over time. I would think in more unequal societies, there will be more, there could be potentially more impact. Having said that, I've worked a little bit on Jordan, for instance, that has extremely low female participation. And although technology is available, the female labor participation doesn't budge. And it doesn't budge because there are far more important societal factors and the social contracts between the genders and the young and the old and the provision of daycare are all extremely important. So it's not like you just put computers on the desk and, you know, women will pour in. Sometimes it happens, like in the US, but even there, as we saw, computers would have brought in more women than the society allowed to. So, so I think there will be societies where societal factors outside technological and economic factors will play much more of a role in restricting the impact of technology. Does that answer your question, Johannes?
So just one Johannes says yes, by the way. One last question from Attila Havas is, what about jobs in which typewriters were not used, but computers are used extensively? E.g. assembly lines, engineers, researchers, call centers, even police cars. Considering those, would that change the picture?
Oh, we have considered all of them. So I just used examples to kind of, you know, give you kind of a sense of the granularity of the data or the kind of information we have, but we have all this information. So when I talk about tools, I don't only talk about typewriters, but you saw some examples. We talk about, you know, power mills and hand tools and all sorts of. So we have, as you saw, the differences between taking the full economy in the analysis and taking manufacturing out are not that drastically different. So what you see here applies for most of the economy and not just secretarial work.
Okay, thank you. So we are out of time. Great presentation. Thank you.
Thank you very much.